Get ready. Because it's been such a long time, I am going to review a few minor concepts with y'all. Okay? The first one is we have two different types of variables, categorical and quantitative. Would anybody like to remind me what the difference between categorical and quantitative variables? Yes.
Categorical is things such as where someone belongs, where the data belongs. I can explain quantitative. It's numbers.
Okay. So for quantitative variable, responses are numbers.
Responses would be words for categorical.
There we go. Thank you. Responses are words. Okay. So, for example, guys, do you think my brain is ever going to get back to normal?
Probably start of next year.
That was actually the best answer I was expecting. I could have gotten the one I was expecting was, has your brain ever been normal, Miss Meister? But just so you guys know, in my head, I started writing the word blonde. I don't know if you guys saw me writing the wrong word, but I started writing the word blonde because in my head, I was already going, oh, hair color is an example of a categorical variable. And my hand and my brain, my brain was on my response to hair color is blonde. My mouth was at the hair color part, and my writing.
Your mouth was not at the hair color part yet.
Oh, yes.
Yeah.
So is this but the level of disconnection is that worse than normal for me, or am I just looking for ways my brain feels out of whack right now?
Kind of sus, Miss Meister.
I couldn't get through the Thursday this morning on the crossword. I got a lot of it, though. It's definitely better than it was last week, for sure. For sure. All right.
Where are you?
I had COVID. So, examples, hair color, and I don't know, something else.
Your shoes tied or untied?
Ice cream versus cookies, right? That was data, wasn't it? And those were categorical variables. And guys, how do I summarize a categorical variable? I ask the whole class if they like cookies versus ice cream.
Categories.
We did a two-way table, right? We could do a two-way table. That's one way. Or couldn't we have said something like, I can't remember. Most of you guys picked ice cream, right? You guys were pretty heavy in the ice cream category. So we might say 70% liked ice cream. We use percentages. Is everybody with me right now? Oh my gosh.
Miss Meister, you weren't even to the ice cream part.
It's so weird. I just feel like all my internal timing is a little bit wrong. Just open it. It's fine. I don't care. I literally don't even care.
He's one of those weird people that breaks off pieces of the cookie that puts that piece in his mouth.
I don't think that's weird. I think that's completely normal.
It is very, just take a bite.
I actually.
Okay. Especially if you're considering sharing the cookie, I'm going to give somebody else a bite.
Jackie's not sharing that.
All right. Hey guys, can someone give me an example? So we summarize categorical variables, we summarize with percents, okay? Does that make sense? If I say we summarize categorical variables with percents. All right, now, can somebody give me an example of a quantitative variable? Number of bites it takes Jack to eat his cookies.
A graph. I know, not examples.
to eat a cookie. It reminds me of this old commercial. How many licks does it take to get to the center of a Tootsie Roll Pop?
I literally wrote that instead of the bites.
That's so funny.
Licks for
Number
Jack
of
to
licks
consume a
for each
cookie.
end of Tootsie Pop.
That's hilarious.
That's a better one.
Leo, I don't know if you want to be on the same wavelength as me today. Hey guys, what do we do to summarize quantitative variables?
I cannot read some of this. I'm sorry. I cannot read what it says with what something under the summarize.
With percentages.
That's a percent sign.
Peters is
Is it?
For quantitative, we can use graphs.
We use graphs. Okay, so hey guys, can we just summarize with graphs for all of these?
yes.
Yes, and Miss Meister loves when we do that. Okay? Even though we haven't been doing that for a while. What like at the end of the day, let's go ahead and say we give Jack 15 cookies and we count how many bites it takes him for each one. This is like a great experiment for you. Like I would love this. If someone said it, Meister, you have to eat 15 cookies so that we can gather some data, I'd be like, sweet. Okay, so after each cookie, we would count the number of bites, and then we would have numbers for each of those 15 cookies. What would we do with those numbers? We can make a graph of them. What else could we do?
Put them in a chart.
Put them in a chart. Like a graph?
Any chart.
Okay.
I think she went to your draft maybe.
Well, we talked about graphs. What else? But, like, that's probably not the only thing you guys would want to do.
I really want to say your mom as a joke. Your mom.
No. No. Wow.
It's funny. I don't know what to tell you. I made it worse.
My smile.
Guys, are you guys like, am I misreading that you guys don't know the answer to this question?
I don't know the
Exactly.
question.
I know exactly what you're asking for. I just forget the term that you need to say.
Like, when I have this list of numbers and I want to do a summary analysis of it, what should I do with that list of numbers?
Make a graph.
Write a paragraph.
We already have graphs.
What are some things we might include in that paragraph?
The hypothesis.
Y-axis, I don't know why.
Man. Okay, I got it. Hey guys,
Quantitative and qualitative.
Hey guys, typically we summarize quantitative variables by finding the average or the mean. Like, we would average all the numbers together to try to make sense of it. I get that you guys weren't there. Are we there now and does it make sense now? Was I overthinking it or?
Put it like something broader.
Oh, no.
It's like, yeah, like mean and average. That's
Like percentages is a very broad thing.
You said summarize it, and I was like, wait, but.
You know, I'm just gonna have a sip of my coffee, and you guys can copy this down. And let's all just.
Breakfast this morning?
I did. I had a English muffin with some provolone cheese.
Oh, you switched it up.
I like provolone cheese and stuff.
Did you have your yogurt with it still?
It's in my lunch.
Miss Meister, do you get the yogurt that you can pour the M&Ms into?
Mm.
I do.
I eat enough candy sugar that I try to get low sugar yogurt.
But that's what makes the M&Ms healthy. Is
All right. So guys, are we now on the same page?
yeah.
And okay. So we're going into we did a whole bunch of like estimates and testing of values when we were taking one sample from one population. This last unit, and this is not your last notes packet, but it is a pre-notes packet for the last unit, okay? What we're going to be doing is finding things to compare two populations. Everybody good? Okay. So let's talk about comparisons. I'm pretty sure this is right. I'm pretty sure Mr. Peters is 6'8". He might only be 6'7".
He's 6'7".
Man. Guys, pretend that says 7.
Did you know he can do a split? In the middle of our class yesterday, he did a split.
I was there. Mr. Peters?
Wait,
Mr. Peters
Mr.
did it.
That doesn't surprise me at all.
How?
He was proving to us that he was flexible.
Because if you look at, not only is Mr. Peters tall, okay, he has really short legs. Like if you look at his body structure, he's got a really, really long torso. So for somebody with short legs to do a split, seems like it might be easier. I don't actually know if that's true, but because I can't. No, I got short everything. So, you know. All right, so 6, 7, and 5, 1. And if I ask you guys to compare our heights, I'm going to tell you the freshman or middle school version of comparing our heights. You ready? Mr. Peters is taller than Miss Meister. Right? That's what you guys might want to say. How could I say that a different way?
Ms. Meister is shorter than Mr. Peters.
And
How much?
yes, that okay.
How much taller is Mr. Peters?
The better question is, what is the difference in height between Mr. Peters and Miss Meister?
About 2 feet.
What is it? What is the difference in height? So, Peters is taller than Meister by 1.5 feet. And how'd you get that 1.5 feet? What math? You did a simple operation. I just need to know which operation you did. Okay. So, are you guys with me? And this is like one of those things that people tend to like trying to figure out the difference between two groups. Kids sometimes don't realize that essentially to find the difference between two groups or to make a direct comparison, you are essentially subtracting two groups.
I think it's easier to add.
Miss Meister needs subtract.
I caught it. I was already changing to my eraser. Yes.
1.5 feet is not 1.5 feet.
We subtract.
But it is.
1 foot 6 inches.
But, however, it is not 1 foot 5 inches. It's 1 foot 6 inches, but 1.5 and 1.5 are equivalent values. But I like that you were at least thinking about it, Leah. Yeah. Everybody good? You ready to roll some more? Okay. Oh gosh. This should be fun. Now, these should have hats on them. So as we're going to learn to start subtracting or comparing two population groups, okay? And what we're going to do is, like, say, if I wanted to compare 7th period to 8th period, right? Or to 2nd and 7th period, you guys, both my FST classes, I would take a sample of you guys, and I would take a sample of 8th period. Okay? 7th period. Pretend I know what I'm doing. Okay. And then what we would do is we would take those two samples and subtract them. Okay. So the rules we're about to get are going to feel very similar to what you guys have always used. Okay? We're just, now they apply to two groups, and what we're going to do is subtract those two groups. Okay? So, in order for anything with p hats to be normally distributed, what we did was n p hat and 1 minus p hat both had to be greater than or equal to 10. Do you guys remember doing that? it is going to change ever so slightly. The problem with doing this is this only applies to one sample, and now we're taking two samples from two groups. So what we're going to do is we're going to do that twice. Once for the first group, and once for the second group. So same rules apply, we're just going to do it twice. Okay? In the center of those, P1 minus P2.
P hat one.
No, it's actually P1. It's going to be the population values. Just so happens we won't know it.
No Delaney, no Lily.
Okay? All right. Now, before, the standard deviation of the p hats was the square root of p1 minus p over n. And again, this is when we had two distributions. Or one distribution, now we have two. So first of all, it's not going to be p hat 1, it's not going to be p hat, it's going to be p hat 1 minus p hat 2. I'm going to put 1s for each of these. And then I'm going to have a second fraction for the second group. And I'm going to throw a plus sign inside. Even though we're subtracting, it's a plus sign. Now, the reason it's a plus sign is this is describing how spread out, how wide the graph or the dot plot of these would be, okay? Now, so as we say that, two groups are going to be more spread out than one group. No matter what. Even if what I'm doing between those two groups is subtracting, the amount of spread is going to go up because I'm going to have twice as much variability. Well, it's not twice as much. Okay. Now, let me go next through an example of this because there's going to be a lot going on here, okay? So I'm going to let you guys read this real quick. I wrote this while covering for Mrs. Sanders' 8th grade class yesterday. And so I did, in fact, feel like I was babysitting middle schoolers. But let's go ahead. You get the basic premise here, is some middle schoolers might babysit and a decent amount of high schoolers babysit.
Could you ever work at a middle school or a preschool?
No. All I need to do is, on my prep period, go out and see the middle schoolers walk over to remind me that I'm in the right place.
If you had to, would you rather be an elementary school math teacher or a middle school math teacher?
Oh, probably middle school. Elementary school students are sticky. Like, they're always, like, sticky and dirty, and they really want you to, like, hug them and stuff, and it's not my jam. I'm not a huge fan of small children. You guys are, like, the
lower limit.
No. Freshmen are the lower limit, and arguable. It might be 10th graders.
Would you ever want to teach like college math, like be a professor?
I'm currently taking classes so that I can teach the college math here.
But like be a professor at a college.
I don't know.
You could show up.
I would make the argument that college students pay to go to college, so they may want to be there even more than you guys want to be here. Though I know how much you guys love coming to school. It's the favorite part of your day. I'm certain of it. Yeah.
Better than me.
Yeah, I mean, yeah.
That could be a
I like it that my work is school because I loved coming to school, but that's because I'm a great big nerd. I love learning. I like knowing things.
Math is not a subject that I don't like, it's just very difficult sometimes.
Sure.
There's a lot of stuff.
It's detail oriented for sure.
And at least it follows rules. They usually don't change. If they change, there's reasons why. And
Yeah.
reasons for those reasons.
Yeah. All right. So guys, let's just start with some like summarizing kind of what we've been told. So guys, tell me something important.
More high schoolers babysit than middle schoolers.
I'd like you to expand upon that, please.
There are 500 high school, oh wait, sorry.
55% of high schoolers babysit.
Okay. So if I wrote down pH equals 0.55, does that help? That the percent of high schoolers is 0.55? And likewise, then I might even write PM equals 0.34. Is that okay? All right. What else do we know? So before, I haven't been using those subscripts nearly as much, right? That subscript is just saying which proportion we're talking about, because now that we're going to have to find ways to keep track of both. And so I'm going to start expecting those little subscripts so I can see that you know what you are talking about. Cool? What else do we know?
There are 700 students.
Okay, but it's important that they're not the same amount, right? So we might say that the N of the high schoolers is 500, and the N of the middle schoolers is 200. Okay? All right. So now, if I want to decide, so here's what we're going to do. I'm going to start my axis here, all right? And guys, if I take a random sample of 500 high schoolers, is it going to be exactly 55%?
No.
Could it be?
Yeah.
Sure. But is it likely to be perfect? Probably not. So let's go ahead and say, pretend I take a sample of high schoolers and I find for that p hat, the high schoolers number is 0.54. And likewise, p hat for the middle school group, is that going to be exactly 0.34? Give me one. What could it be? 0.33. Perfect. Okay. And if I subtract those two samples, so I'm only going to take one sample, and I'm going to find the difference between the two of them. What would that difference be? .21. So
Wait, why is it 0.1 less than the percentage again?
we said what could it be? We're going to do a bunch of these. Okay, so it could be 0.21. Okay? All right. Now, then somebody else is going to take a different sample, and their percentage for them is going to be 0.56 because these are values from a sample, right? And the sample from the middle school is going to be 0.38. And when I subtract those, I get 0.19. So that's this guy. You guys see what I'm saying now? So this is a difference. They're all differences.
0.18.
Yeah, because that's what I said. No, I didn't. You guys just misheard me. There's no way I was wrong.
I think you're gaslighting us.
We have this on recording now.
You realize I'm the one that can control where I erase on the recording,
I
right?
cannot read that again.
It's just little D's. Elena, I think I'm going to move your seat.
Please don't.
Then
I don't want to sit next to Genre, please.
Okay.
she's the worst.
I think I have to drop this class if I sit next to Elena Lee.
So what I'm hearing is, if I want to get rid of both of you, just move your seats. All right, P hat. Let's do one more possible P hat from the high school group. 0.57, and from the middle school group, this difference is going to be 0.29, and I subtract those, and I get 0.28, which might be way over here. Tell me I did that one right at least. Pretty sure I did. And so depending on the 2 samples I get, I could be all over the place. Is this okay? All right, now. So when I'm telling you the rules for normality here, it's describing what is necessary for me to say that this graph is normally distributed. Are you guys with me now? Okay. So what we're going to do is we're going to do that NP 500 times 0.55, 500 times 0.45, and then we're going to do 200 times 0.34, 200 times 0.66. And we have to show that all of these are greater than or equal to 10.
275, 225, 68, 132.
So that approximately normal works. We're good. Elena, then move your seat, man.
I'm thinking about it.
All right. Now, the center of all of this the first thing is, as I wrote that mu out, guys, do you guys see that my subscript is actually 2 different things? It's me saying this is the center of all those different possible samples being subtracted. Okay? Now, you'll love this. This one's the easy one. As Matt said, we can say that more high schoolers babysit, right? How many more on the whole?
21.
21. And you got that by doing 0.55 minus 0.34. So you just take those actual values and subtract them. Yes?
Aren't they not p heads now in this one?
They are not. However, the subscript is not the same thing as these. This is saying the mean of all those possible differences of the different samples. Yeah, I'm with you.
Math is annoying.
Believe it or not, the math of this is not what's annoying. It's the communication that you're finding irritating. It's what the symbols communicate mean of what. The actual calculation of it is not the annoying part. It's what does the symbol mean, which is actually a communication issue.
Chris, I'm not a big fan of Isaac Newton.
This isn't Newton.
I know.
This isn't Newton's notation
I
either.
feel like at some point algebra had to be involved in this.
Sure.
I'm pretty sure Newton invented calculus, not algebra.
Algebra was actually invented in the Middle East.
Okay, well, I don't like whoever made algebra.
Fair enough.
Tax. Not bad.
Okay. All right. So the standard deviation, just like before, is just a formula. You're going to do 0.55 times 0.45 over 500. Like that should feel familiar, as should 0.34 times 0.66 divided by 200. I'm just going to throw a plus sign in between there.
How many calculators do you have?
I don't know, a bunch of mine have in the past week, a bunch of mine disappeared. including my own personal one that I paid for, with my really cool neoprene case.
Well, okay. We have to figure them out for, testing in 2 weeks.
Got it.
Someone stole your calculator.
Great calculator heist of 2022.
Oh. I haven't checked everything.
Announcement to each class. Be like, does anyone have my calculator?
Just be like, whoever has that green calculator, you
Give it.
back.
It's blue.
Oh.
The
Soren
calculator.
has it, Soren knows.
No, I have my own calculator. I always keep it in the case.
Hey, Sam.
I don't have one, but I promise I don't have yours.
I also do not have your
Jack seems to have a blue calculator.
Miss Michael, we'll be on lookout.
Also, did Meister Sharpie
No.
use that?
Also, believe it or not, inside that blue case is a black calculator.
But is the picture in the battery graph of faucet?
Okay. Hey guys. Interesting question. Is that my calculator?
Do you think this is your calculator? That's definitely not.
Okay. All right. Now, hey guys. To do this, we did the high school percentages minus the middle school percentages. What if we had done it the other way around?
Probably be in the negative.
What would be negative?
The shape number.
Okay, the answer to the shape is approximately normal, okay? But when you think about this, only one of these things was influenced by doing high school first. And because you see this plus sign? The plus sign isn't going to change, right? So if I flip-flop the order of these, the standard deviation is going to have the same value. And these were all done separately anyway. So center-wise, that's what's going to change. I was just giving you credit. I pointed at you as I said center. Okay, so the shape is the same. The standard deviation is the same. By the way, did anybody type this in so I know what this answer is?
0.04.
Thank you very much.
Let me just pull up your calculator to do that. It's a joke, I'm sorry.
Because Miss Meister lost her calculator.
You guys, it's not that you guys are in a mood. It's that you're all kind of in this same, like, give it back to me mood, and I don't know what to do with it. I haven't had to worry about my classroom management skills with you guys, like, at all this year. And now I'm like, all of a sudden I have to be the mean teacher or something, and I don't, like, it's like kind of surreal to me.
It's
All right.
because you always gaslight us when you're wrong. We're finally
It actually puts me in a really tough position that all of you feel this comfortable with me when so many of you are taking AP next year. I don't want you to feel this comfortable with me. I want you to still be scared of me. Hey, so guys, what's my new, so I'm going to point out that the notation would change. So this would become P hat M minus P hat H. Okay? And my new center would be negative. Is that okay? And so there's two pieces of this that I want to make sure that you're understanding why I'm even taking the time to point this out. Okay? I am pointing this out because, number one, it is possible to get negative answers for a difference because if you're taking a smaller number and finding in the smaller numbers first, the difference is going to be negative. That's totally fine. Okay? The other reason I'm pointing it out is in some way you need to communicate to me the direction of your difference because it makes a difference. See what I did there? Mm-hmm. All right. So, guys, if I asked you, what is the probability that the percent of high schoolers who babysat is at least 20% higher than the percent of middle schoolers? Here's what we know. To be 20% higher means we're basically saying that the p hat for H minus the p hat for M is greater than 0.2. Thank God we just described the distribution of all those possible differences as having a mean of 0.21, a standard deviation of 0.04. Thanks, Abby. And so if I want to figure out what is the probability of that being more than 20%, I do 0.2, I shade to the right. What do I get? How do I do this? I gotta remember some really old school stuff. Normal CDF.
Oh. You can't do it because you don't have a calculator.
Challenge. Oh, I could put it in my one calculator, but then the recording stops, and then I was going to forget to finish it out, and I don't want to finish out the last piece here, so.
It's sunny outside.
It's supposed to be sunny all day. It's supposed to be a nice day.
I want the rain to come back.
A little, it's supposed to be cool, but sunny.
I like the rain.
I can't remember how to get to normal CD.
Second bars.
Oh, yeah.
Second bars, number 2. Your lower would be 0.2. Your upper would be some really large value.
I believe I have the answer.
What'd you get?
0.598706.
I'm going to call that 598.
744.
That's enough. Okay. All right. Now, what if instead I looked at it, because we also said we could have had the P hat middle school minus P hat high school, and I changed the order that I subtract them. Well, if the high schoolers are 20% or more bigger, that graph would look like this. Well, we just said if we did the middle school minus the high school, it would be negative 0.21. And the standard deviation would still be, except for it would be middle school minus high school, 0.04. This would now be less than negative 0.2. Do you guys see what I'm saying there? Is this okay? You good? You sure? Yeah, I got them. Okay. Is everybody okay? And guys, where is negative 0.2?
It's on the right side.
Just to the right here. Now, look at these two graphs. Are you guys comfortable if I tell you that the answer is still 0.5987? They're like almost like reflections of each other, okay? And the reason I'm pointing that out is it is possible you guys will be having a graded assignment on Monday, okay? And Mrs. Turner is going to be my sub again because I'm not going to be here on Monday, all right? And it's possible that one group, like as you guys compare answers, and that's totally cool with me if what you're doing is actually comparing, like, hey, did you get this? Because I want to make sure, okay? If you guys are comparing answers and your means are different but like negative, and your probabilities are different, the first thing I would look at is, because Miss Meister is smart enough when she's grading it to fix that, okay?
It's going to be a very...
Okay, so shape. Well, when we were just doing one X bar at a time, the distribution for X bars to be normal was one of two possible things. N greater than or equal to 30, or I knew I was sampling from a normal population. So as we're doing this with the 2X bars, guess what? Just like before, it's now N1 has to be greater than or equal to 30, or the first population is normal. It also needs to be true for the second population. So just like yesterday we checked both samples, today we're going to check both samples. Now, yesterday we said the mean of p hat 1 minus p hat 2 was p1 minus p2. The mean of x bar 1 minus x bar 2 is mu 1 minus mu 2. And my standard deviation has changed ever so slightly. Guys, I got the chocolate milk, but I didn't get my coffee yet. While you guys finish copying this down, I'm going to real quick do a little...
Has that been recorded for 43 minutes?
Yesterday's recording, it's on top of yesterday's recording.
Sick.
Okay, y'all. Huh? No.
I can't see it.
It looks like socks because it very much is similar to socks, but it's I loaned these to Mrs. Smith a long time ago. They're like sleeves that you put over your calves when you run. They're compression sleeves. Okay, so let's go ahead and look at this example. The mean number of hours that high school juniors work outside of school is 15.7 hours. Guys, I made that up. Do you think it's close?
Yeah.
No. I would like 20 hours.
Well, so the mean.
Yeah.
There are also people who don't work.
I don't work so
So that would balance out to 10.
Yeah, so then that means that it's off by like 5.7.
And then there's other people, so I'm going to have you just shut up now.
Okay.
Is that too harsh? That was too harsh, wasn't it?
That's on recording, Miss Meister.
Since if it was me or Elena, it's not too harsh.
That's kind of what I was thinking too. Yeah. Okay. So, let's think this through. And then for high school freshmen. Oh. And then I put seniors. And, guys, this is supposed to say juniors. I definitely screwed that up. Which should not shock you in any sort of way.
You're a math teacher, you don't have to worry about the English part, you get all the free passes.
I don't think that's actually true, though. I think I'm still like a professional. Yeah.
I'm still pretend it's true.
All right. So seniors working slightly more hours than juniors is the basic premise. Okay? All right. So with standard deviations, we have all that kind of stuff. All right. Now, let's talk about shape, center, and spread. And as we do this, even though we kind of talked about this a little bit yesterday, I want to make sure we understand for sure what distribution we're describing here, okay? So let's go ahead and say I take a random sample of 31 juniors and I measure their mean. Is the mean of that sample going to be 15.7 hours? No. Is the mean of a sample going to match the mean of a population? No, not necessarily, okay? So the X bar for the juniors could be, I don't know, 14.9? Is that possible? For that particular sample, is that a possible sample? And then the X bar for the seniors, is it going to be exactly 17.1? No, it could be, I don't know, 16.8. And if I'm making a comparison between those two samples, what am I going to do with them? We're going to subtract them, right? And so these two samples, and if I did seniors minus juniors, okay, these two samples would have a difference of 1.9 hours. And that 1.9 is the actual statistic that we're looking at there. Are you guys with me? So we are not graphing these two things separately. And in fact, we're describing the graph where that 1.9 is a possible point. Do you guys understand what I'm saying here now? Okay? It's not the two samples, it's the difference between those two samples. Okay. And so if I want to know if it's normal, I have to check the juniors and the seniors separately. Now, what was my N for the juniors? How many juniors did we sample? 31. I am struggling these days, right? But I am pretty sure that 31 is bigger than 30. But you guys might want to double check my logic on some of these things. Okay? And what about for the seniors?
54.
That's also greater than or equal to 30. All right. Now, and then we're going to do seniors minus juniors, but it doesn't really matter. We kind of talked about that towards the end yesterday. What is the oh, I said this wrong. Get over it. Seniors minus juniors. It's the mean of the graph of the seniors minus the juniors. Okay? But it's one mean, not two. It's the mean of this one graph. And how do I find that? I'm going to do 17.1 minus 15.7. What is it? 1.4. Okay. So guys, this point that was 1.9, it's not here, it's here. This is because the mean is 1.4. And so we should make that 1.9 to the right of the mean, not to the left of it, if you know what I'm saying. Okay, so we said we've got this normal thing going on. All right. Okay.
Can I go to the bathroom, please?
Okay. Now what? Formula went like this, yes? Okay. Do we know the standard deviation of the seniors?
Yes.
What is it? Okay, so we're going to do 6.4 squared over the seniors' sample size was 54. Then we're going to do the same thing with the juniors. Given that I'm giving you those formulas, is this okay?
Yeah.
This feels reasonable?
One point two zero zero four five seven eight nine eight.
1.200. Cool.
Could we just say like 1.2?
Okay. Now, what is the probability? Oh boy, this is a good one. What is the probability that the juniors have a higher mean than the seniors? Let's think this through, okay? I'm going to write that slightly different. Are you guys good for me with me saying that would mean the seniors would be less than the juniors? Okay. So like we can draw this graph. And what's really I want you guys to get here is that this is the graph of seniors minus juniors. Can I turn this into seniors minus juniors? Mm-hmm.
Just have to like turn around the signs to flip-flop.
Say it again. I just
Well, you have to like turn around like the sign.
then I would have juniors is greater than seniors. I still don't have a minus sign. You know what I'm saying? Okay. So how do I turn this into with a minus sign? This is going to feel so silly, guys. Can I subtract the juniors from each side?
Yes.
And I'd get S minus J is less than 0. So if this, so what does it say about the differences if the seniors are smaller than the juniors? It means that their difference would be negative, less than 0. So as like, so Like yesterday, the example we did yesterday, I gave you a specific number to go by. Whereas here I just said one group bigger than or less than the other. And in reality, most of the time, it's going to be something like this. And then we have to kind of rewrite it as greater than or less than 0. I can't have both, but I appreciate the thought.
You can have both.
I
No.
volunteer to take it.
Alright, all of your students here are like, you are a fool, right?
Okay, fine. Let me see what you got in there. If you have the right kind, I'll do it.
You always have to browse before you.
What should we bet on the right kind is for Meister?
What is it?
We can
Chocolate
take a
chip.
statistical sampling.
I am not a fan of chocolate donuts.
Those are the best.
The right kind is in there, you guys. Just
Wait,
take it, take it, take it, take it, take it. You know what? Because you guys are making me do this, I'm gonna eat it in front of you.
Oh, I love the sour cream. Sour cream is so good.
Facts. I
But
got
also
some.
the blueberry one is so
The
good.
blueberries are pretty good.
Yeah. Oh my god. It's so good.
And if you guys have tried their cronut,
Those are the best.
so good.
You know the ones with like the icing and then the icing in the middle?
The Jimmy John's.
Yes. They're
Jenna, I also recorded it.
yes.
Okay. Hey guys, what's the answer? Now that we have the picture, what's the answer?
The numbers.
Thank you. Can we be more specific than that?
I will try. Oh,
How do I find this answer? Normal CDF. You need to throw this into the normal CDF. Please and thank you.
Point 1, 2, 1, 6, 7, 2, 5, 6,
Okay.
8.
Shorin, from here on out, you're not allowed to read every single decimal off the calculator. Come on, man.
Give you the answer.
Huh?
I got a point.
Thank you, Abby. We do have a point, though.
All right.
Do we have to do that?
Would you like examples for your graded assignment when I'm not going to be here on Monday?
I wouldn't know because I went free.
Guys,
We've got these.
here you go. Suppose that 2 large high schools each, we're going to pretend that Grandview and Bexley are very large high schools, okay? We're going to pretend. Okay. So we have the question of interest here is, are people vegetarian or not? Is that categorical or quantitative? Categorical. And how do we analyze categorical variables? We use p-hats. So for this one, we're going to have n for Bexley, we're going to have n for Grandview, we're going to have p-hat for Bexley, and a p-hat for Grandview. All right. Now, so when this happens, we have to use the rules for p-hats. So what is the n for Bexley? Or 75 and 50. We don't know p-hat, we know p. I screwed that up. We know the p for Bexley is 10%. And we know the p for Grandview is 18%. It's probably high estimate, but. So, remember that the rules for these ones are NP and N1 minus P have to be greater than or equal to 10. So we're going to do that twice. We're going to do 75 times, I didn't do a good job of this question at all. Stop making fun of me. I don't know how much longer I get the pass, but you guys got to keep giving me a pass, okay? I'll let you know when you're allowed to stop making fun of me, okay? Wait, where you're allowed to start making fun of me. But it didn't today, I can tell you that much. Hey guys, you want to pretend that 7.5 is bigger than 10 because Miss Meister wrote this problem post-COVID as well? Can we pretend? Man, I'm an idiot. It's literally the worst to like be able to think and not think all at the same time. Feels real icky. All right, then we're going to do 50 times 0.18 and 50 times 0.82. I think this one does work out. No, it doesn't. Does it? It doesn't, does it? It doesn't.
Oh my goodness.
I think it's the
Maybe
same.
we just do the next one. Where did you get the 90 from?
Maybe.
1 minus p?
It does not work out.
It doesn't, does it?
It's 9.
Is it 9.6?
It's just 9.
Oh,
Okay,
it's
guys.
so close.
Guys, we're pretending, okay? Come on, please.
I can't pretend.
Please.
I don't think
I think it's gonna help on the graded assignment till Monday. I'm gonna get start getting a little worried about you this semester.
I'm just
On Monday is when you'll start worrying about me? That's fair. I mean, that's 3 days away.
It's like a weekend to refresh too.
And Monday, because I'm not going to be here.
Oh,
Yeah.
I forgot about that.
This is why we have to get this done, so that you have examples for your graded
I
assignment.
have a graded assignment one day. Okay.
And then I chose Grandview minus Bexley. It doesn't really matter the order. But I do need some help with the answer.
Oh, I got you.
I would like it rounded to 3 decimal places, please.
I was interested in hearing the next installment.
When 064 436014H.
Should I throw the socks at him?
They're not socks.
Yes, you should. You should. You should. Absolutely.
All right. Now, guys, what is the probability that Grandview's sample had 10% more? In this case, like, it is worth noting, like, the direction of this matters, but since we did Grandview minus Bexley, 10% more would be here, this direction. And then, I don't know what the answer is. You're going to throw that in a normal CDF, yes?
Point 377. 3303463.
See? Was this bad?
Yes.
No.
One more example.
No.
We don't need another one because it's like this one and it's the middle is Friday.
One more example, because I'm the boss, you are not. Let's go. Based on the information. Hey, guys, have you ever gone over to the, like, or do you guys remember when you were in middle school and there's like this brief moment, it's about 5th and 6th grade, where all the girls are taller than all the boys? It's like hilarious.
I've been in since
I want to say it's like 5th and 6th grade that like the kids will come over and these girls are like huge and slightly awkward because they've hit their growth spurt, but they haven't really gotten used to their body yet. And the boys are all these little tiny peanuts. It cracks me up. Always makes me laugh to watch those classes. Okay, so
Peanut, bro.
peanuts. All right, now let's go ahead and take a look at this. Tell me all the important information I need to know. All right.
Normally distributed.
The populations, and both populations are normally distributed, right? Okay, so the shape is both populations are normal, so the differences are going to be normal. So that's good. All right. What about the center? Do you guys want to do males minus females or females minus males? It doesn't really matter. Which one did you write down already?
Which one is gonna go along with the
Which one did I write down?
You literally could do both on your graded assignment. That's why it doesn't matter.
Okay.
You want to do females minus males?
I really don't care. I don't.
Okay, so then if I do females minus males, what's my mean?
Wait, that says M X bar and then what's below it?
F for female.
No, see,
Isn't it? Isn't it up as X bars? Those means not being.
no, but like I just.
So we're going to do the 56.4 minus, so the mean of the females minus the mean of the males. And it does, so like it does matter, and it's important that you tell me which one you're doing, but I can grade it whether you, like you're going to get the same answer either way. You're not going to get the same answer here, but I'm smart enough to figure it out, is what I'm saying. So if you got, so the answer here is 0.7, yes? Okay. If you did it the other way around and you did males minus females, your mean is going to be negative 0.7 instead of positive 0.7. But you're going to shade the graph down below in the other direction. And I'm smart enough to figure that out. You understand what I'm saying now? Well, you don't need to, you just need to pick one. You with me? Okay. All right. Now, my standard deviation. But do you guys see how you have to write down this kind of label so I know which order you're planning on doing this with? That's why I'm trying to point this out. Okay? All right. So we're going to do the female fraction first. That will be 2.7 squared over 12. And then the male fraction will be 3.8 squared over 8. Soren, I would like that rounded to 73 decimal places, please.
I don't know if there are that many.
I mean, there are that many. I don't know that your calculator can tell you all of them.
I'm pretty
You
sure.
said 73?
Yeah.
It is a program that you can use to force a TI-84 to list every single decimal until it runs out of RAM.
I think I messed this up somehow, but
I think it was a joke, someone made it. or something.
I would imagine it's, I don't know what it is.
1.553222457 0 0 0 0 0 0 0 0 0 0 0 0 0 0 and then a lot more zeros. So
That's
I get to
it's probably not a lot more zeros though. You're probably wrong.
Yeah, but it's close enough for city.
You were better off saying random digits.
Good enough for city work.
Fair enough. Okay. So guys, I'm going to make the mean 0.7. I'm going to make the standard deviation. And if I say what is the probability that the boys' mean is higher than the girls' mean, what would that say about girls minus boys? So it would be male is less than female. Wait, Greater than female. Our graph is F minus M. You with me? What is true of the value of F minus M if the F is smaller than the M? It's less than 0. It would have to be negative. Okay? That's a normal CDF question.